Welcome. In this video lecture, I am going to talk about the economic order quantity model with non-instantaneous receipt, which is also known as production lot size model or the economic production lot sizing model. So, like one of the assumption in a basic EOQ model is that we receive all the order all at once. Okay, so that assumption we are going to relax in this basically model. So in this model, we are saying that we are basically receiving the order gradually. Okay, as well as we are using that inventory at the same times or depleting that inventory. So because we are receiving, or you can say in a manufacturing environment we are producing that inventory, as well as we are also using that inventory. So the production or the receiving element we are going to represent with P, that is basically the order receiving over the time, or you can say the daily rate of the order receiving, or you can say the production rate. uh, Small d is basically representing the daily demand or the daily consumption rate, but the main point over here is your production rate must be your greater than or equal to your daily demand rate. Okay, so for the small p I am going to use for the daily production. For the capital P I'm using for the annual production rate. Same as the capital D, we are using the annual demand, and small d is going to use for the daily demand rate, right? So again, in this model we are saying that no plant shortages are allowed, right? So how we can represent this model graphically? So on a x-axis, once again we have a time. On a y-axis we have the inventory level. Okay, so how we can represent graphically? So this is going to be indicating this is the production rate, because this is the speed in which we are producing. Because the p is greater than or equal to the d, which means the production rate is greater than the demand rate, so the slope of this line is going to be equal to production rate minus the demand rate. So at this particular speed we are basically piling up the inventory of that particular SKUs. At this particular speed we are basically using or consuming this particular SKU. Okay, so if we divide this order cycle, so this is basically the one order cycle. Okay, so if we divide this order cycle into the two parts, so that means in this particular time we are just receiving, or in a manufacturing environment we are just producing that particular product, whereas in this particular time we are consuming that particular SKU, right? Okay, so first of all, we know that how to calculate this order cycle time, that we can calculate with the Q by D. Okay, so that is the order cycle time, or you can say the overall production interval time, right? In which basically we are saying that how long this production interval is go long, or you can say the production time is going to be long. Not the production time, basically the order interval or the cycle interval is going to be long. So in order to find out only that particular time in which we are just producing, so how you can calculate that one? That is basically we are talking about this one. Let's say we call it as T1. So the T1 is going to be the production rate divided by the demand, right? That is in which we are basically producing the thing, right? So similarly, in order to find out that is what would be the T2, that is how we are going to consume that one. So we can calculate that one, that is the maximum inventory we have divided by the demand. So now the question is how we can find out what would be the maximum inventory of that particular SKU. So in order to find out the maximum inventory level, let's assume that right now the maximum inventory we have, that means this particular level is equal to y. Okay, so for that we can say that this particular time would be y over p minus d. That is basically the time interval in which we are basically producing, or you can say in which we are piling up the inventory. Okay, plus y over d is basically the time in which we are consuming, which must be equal to q by d, that must be equal to the overall order cycle time. If we basically solve this one, we would be able to get the y, which is basically indicating the maximum inventory level. So the maximum inventory level is going to be this one. So which means the T1 is going to be P by D, that is the production time. Okay, or you can say that the time in which we are basically piling up the inventory, and how much we are piling up the inventory, the how much we can say that we can calculate this one. But in order to find out the time, we can find out the time in this way. Whereas in this particular time we are basically consuming this particular product, and how we can do that, that is going to be the maximum inventory divided by the D, that is the time in which we are consuming that particular product. So once we know the maximum inventory, okay, now we can calculate the average inventory cost. So how we can calculate the average inventory? So that is going to be the maximum inventory we have divided by 2 would be the average inventory. So once we know the average inventory, we can calculate the carrying cost. That is going to be the average inventory multiplied by carrying cost per unit. That is the basically the total carrying cost, or you can say the average carrying cost, right, per cycle. Plus how we can calculate the order cost, that is the C naught is going to be the order cost per order multiplied by D by Q, that is the number of order we are going to place in this entire time period. So as you can see that this total cost is similar to the basic QQ model, but over here this element is the additional element, right? So we are just keeping in that mind, and we can use the basic EOQ model function. And we know that in a basic EOQ model, the formula of the optimum order quantity is 2C naught into D over CC. Or even if you would like to find out, you can take the first order derivative with respect to Q and put it is equal to 0, you would be get the this optimum order quantity. Okay, or you can say that in an optimum order quantity we need to add this element, okay, as you can see over here. Or then take the second order derivative, and that second order derivative with respect to Q must be greater than or equal to 0, right? And from the basic Q model, from the sensitivity analysis part, we know that the total order cost against the optimum order quantity would be equal to 2 into C naught CC into D. And now we are adding this part, that is basically due to that gradually receiving that product. So the optimum order cost we can also calculate with this one. So as we have already discussed, this is the number of orders. This is basically the time in which we are basically placing, you can see the order cycle time overall, and this is basically the production run time. So I hope you got the idea regarding the economic production lot sizing model. So let's solve one question. Suppose we have the annual capacity that is equal to this one, we have the annual demand is equal to this one, okay, and the cleaning preparation setup cost, basically this is going to be the order cost, which is a C naught, and the carrying cost we can calculate with the help of this one, which is the manufacturing cost multiplied by the holding rate, which means 4.50 multiplied by 0.24, and the number of days they are working, which is 250 in a year. So in order to calculate the optimum cost, so this is basically the annual demand, which is capital D. In order to calculate the daily demand, we can use is annual demand divided by the number of days they are working in a year. So this is the annual production capacity, okay, and divided by 250 would be the daily production capacity. This is the carrying cost we are getting after multiplying 0.24 multiplied by 4.50, which is this one multiplied by this one, and then this is the order cost, right? So once we put this into the optimum order quantity formula, we would be able to get the optimum production lot size. Then we can calculate the total cost. So put the value in the total cost function, we would be able to get the total cost answer. In order to calculate the number of production runs, or you can say number of production cycles or the order cycle, that is going to be capital D over Q star, so which is going to be 7.674, right? Now the next thing is we need to find out the idle time between the production run. What does this mean is that mean when we are basically finishing the production over here of this particular SKU, okay, then how long our production is going to be idle or wait in order to meet start producing the next one. So how we are going to use what we are the concept we are using is that is the length of the order cycle time minus the length of the production run, or you can say the production time. So in order to calculate the idle time, we are saying that the each production time is going to be q by d. Okay, that is basically in which we have the entire order cycle, or you can say the production cycle, multiply by 250 in order to get the production cycle or the order cycle into the days. And then we are calculating the time to produce this unit. So time to produce this unit is going to be q star divided by the p. Okay, which is q star is equal to this based on the annual demand divided by the p is 240. So we are getting this one. So 32.5 minus this one, we are getting the idle time. Similarly, in order to calculate the last part, which is the utilization of the production line, that is going to be annual demand divided by the production or multiply by 100. Okay, or either you can use the time, which is going to be the idle time, okay, divided by the total order cycle time, that is going to be indicating the utilization of the production, right? Okay, now in this model, we have seen that this is the economic production lot sizing when we are not considering any setup. Okay, but let's say if there is a setup time, because if I am producing one SKU, after finishing that production of that particular SKU, I need to produce another in SKU. Okay, so if there is a setup time, so that means there is a time in which we are preparing that production line or the equipment. So that is called as a setup time, which we are representing in tau. Okay, and the idea we are using, if we are using the economic production lot sizing and there is a setup time, so how we can decide how much batch size or the lot size or how much order we are going to place, that is going to be considered based on this equation. So what is this equation is, that is basically the time in which we are consuming the product. Okay, which is basically the 2 to t2. That was basically the maximum inventory we have, and how we have calculated the maximum inventory in economic production dot sizing, which is q star into 1 minus d by p. Okay, this is the a maximum inventory divided by the rate in which we are consuming. So this is the maximum inventory divided by this is a t2. So if t2 is greater than the setup time, okay, so using this one, we are basically simplifying and we are saying that after cross multiplying, so this is the economic order quantity model which we are going to use basically with the help of economic production lot sizing model. Okay, must be greater than or equal to, which we have seen earlier. Okay, the formula. And then the right hand side is this one. So we are saying that if the economic production lot sizing value is greater than this one, we are going to calculate the order size or the order quantity with the help of this one, or you can say the lot size with the help of economic order quantity formula, which we have seen earlier. But if this value is smaller than this one, then the economic production lot sizing value would be equal to the answer of is equal to this one, as I have seen over here, right? So I hope you got the idea what is economic production lot sizing model without setup, and if there is a setup time, how you are going to deal with this one. So thank you so much. See you in the next video.